So deforestation contributes significantly to climate change, biodiversity loss, and environmental degradation. Indonesia is among the top 5 countries experiencing severe forest loss, with 230,000 hectares of primary forest lost in a year, releasing 177 million tons of carbon emissions. Despite commitments to halt deforestation by 2030, weak monitoring and enforcement remain critical challenges. Existing monitoring systems such as Simontana face limitations in coverage, speed, and data verification. Accordingly, we need a more responsive, enhanced real-time forest monitoring, especially in remote forests with limited internet. Hence, the study proposes an IoT-based deforestation mitigation system where we integrate a mesh network and solar power to enhance real-time monitoring in remote areas without reliance on conventional signals to address this issue.
The objective of the study are as follows. 1. To identify the development process of integrated deforestation mitigation technology based on IoT with mesh network applications and solar energy utilization as an advancement of the Simontana system. 2. To evaluate the effectiveness of integrated deforestation mitigation technology based on IoT with mesh network applications and solar energy utilization in advancing the Simontana system.
So the process of this study begins with a literature review where we analyze existing research and technologies in forest monitoring, and this is followed by problem identification, assessing gaps in current systems such as Simontana. Next, the requirement analysis determines the necessary components and functionalities for an improved monitoring system. Based on its findings, the design phase focuses on developing a mesh network integrated IoT system powered by solar energy. Following the design phase, implementation begins where the system is built and configured with sensors for detecting deforestation activities. To ensure reliability, the system undergoes testing including vibration, fire, and in temperature. Post-testing and analysis and review phase evaluates system performance. If the system meets specification, the study concludes. If not, refinements are made before re-evaluating.
The mitigation device components include a solar panel for power source with a charge controller, a microcontroller. In this case, we use a Node MCU ESP8266. We use an NRF24L01 wireless radio module. We use an SW420 for vibration detection, a KY026 for fire detection, a DHT22 for temperature and humidity monitoring, and we assembled the circuit in a breadboard for testing purposes. For the software, we used Arduino IDE to program the microcontroller, we used Node.js and Express.js for the back-end server, we used React.js for the front end, and we used EasyEDA for designing a PCB for long-term reliability.
The testing schemes used to evaluate the apparatus are as follows. First, the vibration test for the SW420 sensor, where we assess the sensor's ability to detect vibrations at distances from 5 cm to 100 cm with 5 cm increments. Each distance is tested 10 times for accuracy. Secondly, the fire and radiation test for KY026 sensor, where we evaluate fire detection range using a lit candle as the source. Measurement range is 5 cm to 100 cm, recorded manually with the ruler. Lastly, the temperature test for the DHT22 sensor, where we compare sensor readings with the thermometer at 30, 60, and 90-minute intervals. Accuracy percentage is calculated based on the comparison of the two tools. The test results of the apparatus are as follows. First, the vibration test results shows that the SW420 sensor has an optimal range of 5 to 15 centimeters, where it shows 100% success rate, whereas there is a moderate performance within the 20 to 35 centimeters, as well as the 40 to 50 centimeters, where it shows 90% and 80% success rate respectively. Significant decline beyond 55 centimeter exists, where it drops to 10% at 100 centimeters. So the implication that we can take is that limited range must be considered for large area monitoring. Adding sensors or improving sensitivity could enhance its effectiveness. Secondly, for the fire and radiation test results, the KY026 sensor detection range is 10 to 90 centimeter, where the sensor indicator is on, and it fails at 100 centimeters, where the sensor is off. So the sensor effectively detects fire within its range with reliable visual feedback. Lastly, the temperature test result for the DHT22 sensor shows that the DHT22 readings range from 31.60 degrees Celsius to 32.6010 degrees Celsius, whereas the thermometer readings range from 31.90 degrees Celsius to 32.60 degrees Celsius. The minor variations there exist but remain within an acceptable range for environmental monitoring. Hence, the sensor provides consistent and reliable temperature readings for environmental monitoring.
In conclusion, this technology has been developed by integrating the SW420, KY026, and DHT22 sensors with the Node MCU microcontroller. The data collected from these sensors is transmitted via the NRF24L01 wireless module within a mesh network, allowing communications without reliance on conventional internet infrastructure. Data from the device is transmitted to a server based on Node.js and Express.js and then visualized through a React.js-based user interface. Testing has demonstrated that the system is highly effective in detecting activities that could potentially lead to deforestation. The vibration sensor operates optimally up to a distance of 25 cm within 90% accuracy. The fire sensor detects within a range of 10 to 90 cm, and the temperature sensor exhibits a deviation of 0.5 degrees Celsius from a standard thermometer. Thus, the system can be adapted as an enhancement to the existing simultaneous system. Overall, by utilizing IoT technology, wireless mesh network, and solar energy, the system is capable of gathering data that accurately represents forest environmental conditions. Therefore, this research represents a progressive step in protecting Indonesia's forests and ecosystems by enabling effective identification and response to deforestation threats.